please label your page Chapter 1, Tools of Geometry, Section 4, Measuring Angles. Make sure you date your page, and if you need to put a page number on the top. So an angle is formed by two rays with the same endpoint. Now these are not opposite rays. Opposite rays form a straight line. These are two separate rays, but they share a common endpoint. So we can see here, we have ray RS, and we have ray RT, and they share the common endpoint R. Now we can also see that this is the interior of the angle, and everything else outside is the exterior of the angle. The rays are the sides of the angle, and the endpoint that they share is called the vertex. Now there's four types of angles that we're going to talk about here. The first is a straight angle. So here's the vertex, and the two rays form a straight angle. Which means it's 180 degrees. So it's a straight line, and the angle is referred to as a straight angle. The measure of the angle, so in this case, we write it as the measure of angle SRT is equal to 180 degrees. Now, whenever you're talking about equivalency, whenever you're writing equal to, you're going to write the measure of the angle. If you're just talking about the angle and it being congruent to another angle, then you leave out the M and you write angle SRT. An acute angle, an example of an acute angle would be something like this. Let's say the measure of this angle was 30 degrees. An acute angle must have a measure that is less than 90 degrees, but obviously greater than 0 degrees. So it has to be in between 90 and 0 degrees. A right angle, on the other hand, has to equal exactly 90 degrees. So a right angle would be something like this. Angle PQR. And we showed that it's a right angle by putting a box in the corner. Finally, we have an obtuse angle. An example would be something like this. Make sure your lines are straight. Angle LMO. Let's say the measure here in the example is 130 degrees, just as a sketch, not using a protractor or a compass. And important about an obtuse angle, it has to have a measure that's greater than 90 degrees, but it has to have a measure that's less than 180 degrees. So we can see straight angles and right angles have to equal a specific amount. So a straight angle has to be 180, a right angle has to be 90. Acute angles, however, have to be greater than 0 and less than 90. And an obtuse angle has to be greater than 90 but still less than 180. So this brings us to congruent angles. Now, we talked about congruent segments. When we had two line segments, line segment AB and line segment CD, we said that we showed that they were congruent by putting a single line through each segment. So this shows that line segment AB is congruent to line segment CD. And we said when we were talking about their measures, we'd write it as AB is equal to CD. It's similar with angles. When two angles are congruent, you're going to see that they have the same number of loops in the corner of the angle by the vertex. And let's say this was angle RST, where S is the vertex. and this is angle LMO with M as the vertex. We would say when we're talking about congruency that angle RST is congruent to angle LMO. If we wanted to say that their measures were equal, we would say the measure of angle RST equals the measure of angle LMO. So when we have congruency, there's no M in front. When we're showing equivalency, we write the measure of the angle in front. Now when we move into triangles, we're going to have, let's say, two triangles. Those have 3 angles each. So let's say that these angles are congruent. So we have these angles congruent. In order to show that different angles are congruent, instead of just putting 1, you'd put 2 little circles, half circles, in the top angle. So now we can see these angles are congruent to each other because they have that single arc, and these angles are congruent to each other because they have that double arc. But the blue is obviously not congruent to the red. Now, similar to the segment addition postulate, there's the angle addition postulate. So if point B is in the interior of angle AOC, so first let's draw angle AOC. And B is in the interior, so B is in the interior. This is the interior, everything else is the exterior. They want to show that the measure of angle AOB, so let's say that we drew a ray going out from O to B, the measure of angle AOB plus the measure of angle BOC equals the measure of the total angle. Now notice I only put 1 arc here and 2 arcs here. That means that they're different measures. So let's say the measure of angle AOB was 23 degrees, and the measure of the entire angle, the measure of angle AOC, is 70 degrees. In order to find out the measure of angle BOC, we would have to do 70 minus 23, and that would give us 47. So angle BOC must equal 47 degrees. Now there will be times where you're using algebra in order to solve these. So let's say they tell you the measure of angle AOB is 3x plus 4, and the measure of angle BOC is 2x plus 5. They will then give you a total measure of the entire angle. So let's say the measure of angle AOC, the total measure, is 59 degrees. That means the measure of angle AOB, 3x plus 4, plus the measure of angle BOC, 2x plus 5, has to equal 59 degrees. Combine like terms, 3x and 2x gives us 5x, 4 plus 5 gives us 9. Inverse operations, we were adding, so we're going to subtract 9 from both sides. 5x equals 50. Divide by 5 on both sides, which means that x equals 10. If x equals 10, then we're going to plug it in. So here, 3 times 10 is 30, plus 4 gives you 34 degrees. And here, 2 times 10 is 20, plus 5 gives you 25 degrees. And you can see that 34 plus 25 gives you 59 degrees.